Write the ASCII 7 coding for word girl, that is capital girl, GIRL. Here all letter is in capital letters. We know that in ASCII code, uh, uppercase letters have different code than lowercase letter. Here girl is written, we have to write ASCII code for girl and with uppercase, because G is capital, I is capital, R is capital, and L is capital. Now from previous lecture, we see the different ASCII code for different characters. So here in binary, G is written as 10000111, and in hexadecimal it is 47. I, uppercase I, it is 1001001 in binary and 49 in hexadecimal, and uppercase R 1010010 in binary and 52 in hexadecimal, and L 1001100 in binary and 4C in hexadecimal. Now we combine it from left to right. So ASCII coding for the word girl will be 100011001100101010101100 in binary coded, and in hexadecimal it will be 4749524C from left to right. Again with another example, write the ASCII 8 code for word John. Here J is capital and other letter is small, or J is uppercase and other letter is lowercase. Here we have to keep in mind that lowercase letter has different uh, coding than uppercase letter. So now we write the binary code for J is 01001010 capital J, and binary code for a small o is 01101110 and 6F in hexadecimal, and a small h has binary code 011010G0 and 68 in hexadecimal, and a small n has binary code 01101110 and 6 in hexadecimal. Now arranging it, we get the binary code as 0110111011101110 and its hexadecimal binary code will be hexadecimal ASCII code will be 4A6F66886E. Now, since each character in ASCII 8 requires 1 byte for its representation, and there are 4 characters in the word John, 4 bytes will be required to store this word using this coding. Now, the next topic is our Unicode, and we see what is Unicode. As computer become a popular tool for doing all kinds of data processing across the world, their uses could not be limited to English language users only. Hence, people started developing computer systems that could allow interaction processing of data in local languages of users. For example, Korean, Chinese, Hindi, Japanese, etc. This requires support of local language characters and other language specific symbols on this computer system. ASCII or FSDIC did not have enough number of bits to accommodate all the characters and language specific symbols of a local language. In addition to English alphabet characters and a special character, hence different encoding systems were designed to cater to this requirement of different local language. In this process, hundreds of different encoding systems came into existence. Although this looked fine initially, but later led to a chaotic state of affairs due to following reasons. Because no single encoding system had enough bit and an adequate mechanism to support characters of all types of language used in the world. Hence, supporting of characters from multiple languages on a single computer system become a tedious job, and it required supporting of multiple encoding systems on the computer. With hundreds of different encoding systems in use across the world, it became almost impossible to support all of them on a single system. The next reason is that different encoding systems developed independently of each other obviously conflicted with one another. That is, two encoding systems often use the same code for two different characters or use different codes for same characters. Due to this problem, whenever data transfer took place between computer system or software using different encoding system, the data was at the risk of corruption. So, to solve this problem, a new system of coding is developed, and that is called Unicode. And it is the so a new system is required that every computer can use that, and so Unicode is where developed. As a result, it became difficult to exchange text files internationally. The Unicode standard was designed to overcome these problems. It is a universal character encoding standard used for representation of text for computer processing. The official Unicode website www.unicode.org/standard/whatisunicode.html states that it is an encoding system that provides a unique number for every character, no matter what the platform, no matter what the program, no matter what the language. Now some useful features of uh, Unicode. Today, Unicode is a universally accepted character encoding, and these are the features of this coding. It provides a consistent way of encoding multilingual plain text. This enables data transfer through different systems without the risk of corruption. Second, it defines codes for character used in all major languages of the world used for written communication. This enables a single software product to target multiple platforms, languages, and countries without re-engineering. Next point is that, and next feature is that it has the capacity to encode as many as millions characters. And this is large enough for encoding all known characters, including all historic scripts of the world as well as common notational system. Next point is it also defines codes for special characters such as various types of punctuation marks, mathematical symbols, Diacritics, technical symbols. Diacritics are modifying character marks such as tilde that are used in conjunction with base characters to represent accented letters indicating different sound. For example, and tilde. It assigns Next point is that it assigns each character a unique numeric value and name, keeping character coding simple and different. Next point is it reserves a part of the code space for private use to enable user to assign codes for their own character and symbols. Next point is it upholds simplicity and consistency of ASCII. Unicode character that correspond to the familiar ASCII character set name the same byte values as that of ASCII. This enables use of Unicode in a convenient and backward compatible in environments designed entirely around ASCII like Unix. Hence, Unicode is usable with existing software without extensive software rewrites. So, Unicode has a lot of room to accommodate new characters. Moreover, its growth process is strictly additive in the sense that new characters can be added easily, but existing characters cannot be removed. This feature ensures that interpretation of data once encoded in Unicode standard will remain in the same way by all future implementations that conform to original or later versions of the Unicode standard. Now we see the Unicode form. Unicoding form. In addition to defining the identity of each character and its numeric value, also known as code point, character encoding standards also define internal representations, also known as encoding forms of each character. How its value is represented in bits. Unicode standard defines following three encoding forms for each character. First is UTF-8, that is Unicode Transformation Format 8 or UTF-8. This is a byte-oriented format having all Unicode characters represented as a variable length encoding of 1, 2, 3 or 4 bytes. Remember, 1 byte equals to 8 bits. This form is useful for dealing with environments designed entirely around ASCII because the Unicode character that correspond to familiar ASCII characters set have the same byte value as that of ASCII. This form is also popular for HTML and similar protocols. The next is UTF-16, Unicode Transformation Format 16. This is a word-oriented format having all Unicode characters representing as a variable length encoding of 1 or 2 words. Remember, 1 word equals to 60 bits. This form is useful for environment that need to balance This form is useful for environments that need to balance efficient access to characters with economical use of storage. This is because all the heavily used characters can be represented by and accessible via a single word or 16-bit code unit, while all other characters are represented by and accessible via a pair of words. Hence, the encoding form is reasonably compact and efficient. It provides support for larger number of characters. UTF-32 Unicode Transformation Format 32. This is a double word oriented format having all Unicode characters represented as a fixed length encoding of two words, remembering one word as a 16 bits. That is a double word 32-bit code unit encodes each character. This form is useful for environments where memory space is not a concern but fixed with single code unit. Access to the character is desired. Now notice that at most 4 bytes 32 bits are required for each character in all three forms of encoding. With the three forms of encoding supported, transmission of the same data in a byte word or double word format, that is in 8, 16 or 30 bits per code unit, is possible depending on its usage environment. Unicode standard also provides the facility to transform Unicode encoded data from one form to another without loss of data. Next, see collating sequence. What is collating sequence? Data processing operation often use alphanumeric and alphabetic data elements. Obviously, we do not intend to perform all arithmetic operation on such data, but we frequently perform comparison operation to them, like arranging them in some desired sequence. Now, if we want a computer to compare alphabetic values A and B, which one will the computer treat as greater? Answering such question necessitates having some assigned ordering among the characters used by a computer. This ordering is known as collating sequence. Data processing operation mostly adopt case-sensitive direct dictionary collating sequence. Collating sequence may vary from one computer system to another depending on the type of characters in coding scheme or computer code used by a computer. To clear this, let us consider the computer codes already discussed in the previous chapter or lecture. We know the zone values of character A through 9 decreases in BCD code from the equivalent of decimal 3 down to 0, while the zone values of character A through 9 increases in FDIC form from the equivalent of decimal 12 to 15. Hence, a computer that uses BCD code will treat alphabetic characters A to Z to be greater than numeric characters 0, 1 and 9, while a computer that uses FDIC will treat numeric characters to be greater than alphabetic characters. Similarly, observe from the previous example, during a sort or ascending, a computer using ASCII will place numbers ahead of letters because numbers have values less than that for letters. Due to similar reason, it will place uppercase letters ahead of lowercase letters. However, whatever be the types of computer code used, in most collating sequence, following rules are observed. First rule is that letters are considered in alphabetic order, that is A less than B less than C, that is uh, alphabetic order, in ascending order. First we tell A, then B, then C. That is B will be greater than A, C will be greater than B. Like so, Z will be greatest in the letters. for both uh, uppercase letters or lowercase letters. And digits are considered in numeric order also. For example, 0 less than 1 less than 2 less than dash 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 less than 9. For example, a computer uses FSDIC code as its internal representation of character. In which order will this computer sort the strings 2, 3, A1 and 1A? In FSDIC, numeric characters have value greater than alphabetic characters. Hence, the said computer will place numeric characters after alphabetic characters, causing sorting of the given string as A1 less than 1A less than 2, 3. Therefore, the shortest sequence will be A1, 1A and 2, 3. Next example. A computer uses ASCII for its internal representation of characters. In which order will this computer sort the string 2, 3, A1, 1A, a small lowercase a2, 2A, AA, and AA? In ASCII, alphabetic characters have values greater than numeric characters and lowercase letters have values greater than uppercase letters. Hence, the said computer will place numeric characters before uppercase letters and it will place lowercase letters after uppercase letters, causing sorting of the given string as 1A less than 2, 3 less than 2A less than understand it as like 1 cap A less, here cap A means capital A or uppercase letter, 1A cap A less than 2, 3 less than 2 small a, that is number digit is 2 and letter is a letter is a smaller or lower case letter. Again cap A1 less than cap a small a less than a small a2 less than a small a cap a. Therefore, the shortest sequence will be 1 cap a 2, 3, 2 small a cap a1 cap a small a2 and a small a cap a.